And so let us welcome Sir Rico Maestro.
Okay. Good morning, everyone. Again, thank you for attending this workshop about GDP. So, I will be discussing the GDP overview and later a tutorial on how to use GDP in an application. So, for this project, for the Sense project, I am in charge of the development of the Sense control or Sense central service that Sir Mong mentioned earlier. Okay. So, just a brief background again. The GTP is developed by the Swarm Lab, which is headed by Sir Yan Rabay, as mentioned earlier. So here's an outline of my talk, just to guide you of the flow of our discussion. First, we will discuss a brief discussion on IoT or Internet of Things in the Swarm. Basically, what is the motivation of the Swarm Lab in creating a new platform called the GTP. Then we'll go to GP and to its specific details like the global channel logs and the benefits of the log structure and a brief discussion regarding the routing protocol of the GP. Okay. So, as mentioned earlier, for the past few years, the Internet of Things and the Swarm is being well known in the industry and even in research. Okay? So, different research projects are actually using the IoT either for utilization of the data from these sensors or by creating new or developing or improving the Internet of Things. Okay, so there are two general application types of IoT applications. So first, we have the ambient data collection for feature analysis. So in this case, this is the more of monitoring applications as mentioned earlier in Sir Yan's talk. This is the starting part of the IoT where you just deploy different sensors in the environment, then get the information from there, store it, then for future use, you're going to analyze this data. Basically, what is the trend of the data and what are decisions that you can make regarding these trends. Okay? Then the second part or second type of applications are the real-time applications with low latency requirements. So these are the applications that have control loop. Basically, you have a sensor. Then in real time, you're going to analyze the data from those sensors and decide and let an actuator what do you call this? Let an actuator react so that you can change the parameters of the environment that you are monitoring at the same time you are controlling. Okay? So these are the two types of Internet of Things application. And these two types actually has different requirements. For example, for the first application, you actually don't need a low latency requirement as long as the data will be preserved or will be stored in the cloud. Okay. However, for the second part, for second application, you actually need low latency requirements for this one because the application might have crucial effects or critical effects if you were not able to control the loop in real time. Okay, so now we're using the cloud architecture. However, there are some issues regarding the cloud architecture in if you apply that for these two types of application. Okay, so what are the issues of Swarm and the cloud architecture? First, we have the sub-optimal cloud. Okay, so the cloud is basically a hub of different computing devices in the internet. So for an application developer's perspective, I just view that as a single computer. Okay? However, in a networking perspective, we know that the cloud is actually at the edge of the network. So it is not that optimal because, for example, for web applications like YouTube, okay? So I believe almost everyone here streams content from YouTube, okay? So these kinds of applications have cache in different localities, okay? Where, if for example, if a certain resource or a certain video gets popular demand on a certain location, the web application service will try to cache that resource in a much nearer machine such that to reduce latency when requesting that resource. However, for Internet of Things application, we don't have that capability. For example, if you have real-time applications, this cache don't have intelligence on its own. Okay, so they cannot react on the data that your sensors are getting. So if I have a data or sensor node in one edge of the network, and my application that processes that network is on the other edge of the process that data is on the other edge of the network, there's a possibility that we will have an unpredictable latency when sending data from the sensors to the processing, and from the processing to the actuators. Okay? So that's crucial for real-time applications. The second issue is security and privacy, as mentioned earlier also in the message of Yan. Okay? So since we have Internet of Things, we have different systems here, from sensor devices, from the to the links between the sensors, to your aggregators, your base stations, to the network. And since you have that large surface area, there's a difficulty in creating an secure end-to-end flow of data. So the GDPs will try to minimize that attack surface area. The third issue is the QoS requirement, or quality of service requirement, which is somehow tied on the first two issues of the smart cloud architecture. And the last is the durability management, basically the existence of data. For example, for the first type of application earlier, I need my data to be present all the time. Okay? However, for the second type of application, for real-time applications, I can choose not to save the data that I have, or I can choose that this kind of data will be deleted after some amount of time. Okay? However, when using the cloud architecture, we are not sure if these data are actually deleted, since we don't have control on the cloud. Okay? So the GDP tries to give control to the user on how he or she will use the data, how she will use or how will we preserve the data. Okay. So that's the premise of the GDP. Basically, it is centered on the data that you want to store. Okay, so it's a data-centric abstraction focused on distribution, preservation, and protection of information. So these are the three focus of the global data plane, and I will discuss it later. So the key mechanism for the data storage is using a secure single writer append log. So this is basically the file or database that I'm using for the GDP, or that is the GDP uses. So the GDP still works on top of TCP, but since I only need to know which logs I need to access, or need to write, or to read from, I don't need to know the specifics below the network layer, or below the GDP layer. Okay? So one problem here is, for example, if I have an application, I have a base station, I need to know the IP address of that base station to send my data to that station. Right? However, we know that the IP address can actually change depending on the network structure. So for this GDP, instead of using IP addresses, we use human readable names. Then the GDP will be able to map those names to the specific location or specific machine where those logs are being stored. So you don't need to know which IP address, or if there's a change in the network structure, you don't need to know or to keep track that new IP address. You just need to know the name of the log, as I'll discuss later. Okay? So again, the global data plane is on top of the TCP/UDP protocol. Then above it, we have the common access APIs, which helps us developers to easily interface the applications that we are developing with the GDP. Okay. So I mentioned earlier that the key mechanism, or the key storage mechanism of the GDP is the logs, or in the GDP language, it's called the GCL, or the global channel or log. So it is a time series append-only data structure, which means that any data that you put on it will not be deleted unless, okay, there's an unless part there, that you define in that GCL that after an amount of time, the data will be deleted. Okay? But in default, any data that you put or you append on it will not be deleted. Okay? So the GCL or each GCL has an addressing of a flat 256-bit identifier. So this 256-bit identifier is on the GCLs, on the GTP side. However, we have abstractions, as we mentioned earlier, that the GTP can actually, you can actually assign a human readable name. For example, I can assign Rico.log on a log, and it will be converted to a 256-bit identifier. Okay? So instead of, again, I mentioned earlier, instead of having or knowing the IP address, okay, I can memorize this 256-bit, but that will be very, it will be a hassle. So I can actually instead memorize the human readable name that is associated with this identifier. Okay? So the GCLs are authenticated data structures stored or potentially trusted infrastructure. So later we'll see that once you create a GCL, you'll actually create a key, okay, a public key that you'll be using to sign future appends. Okay? Which means that although the human readable name can be known by different clients, okay, by different writers, if they don't have the key for that GCL, they won't be able to append new information. Okay? Then the GCLs are potentially distributed over multiple physical machines. So one premise of GDP is that they want to make the whole data storage distributed. Okay? So for example, if I have a client here in UP and I have a client somewhere in UC Berkeley, okay? Instead of having a log that is stored in the Berkeley servers, the GDP can have a replication mechanism that replicates the information from the servers in the UC Berkeley to the servers here in UP Diliman, okay? To minimize the latency in sending the information. As mentioned earlier, the GCL are single writer logs, but can have multiple readers. So upon creation of GCL, again I mentioned earlier, a public key will be created, okay, that will be used for future validation of appends to the GCL. Okay, so again, you won't be able to, other people won't be able to write new information if they don't have that public key. Okay? And it can have multiple replicas mentioned also earlier, depending on high-level policies. Okay? By default, you actually define which server will host your GCL. But I believe, I'm not sure yet if it's already implemented. Because the GDP is actually a work in progress in Berkeley. Okay, so they already have the first initial versions with the basic functionality, but they're still developing other functionalities. Okay? So again, you can have multiple replicas depending on the high-level policy decisions on the GCL, and you have some kind of directory service that associates human readable names to the 256-bit GDP identifier that I mentioned earlier. So instead of memorizing that 256-bit, you just need to know the human readable name. Within the GCL, each write or read to allow means you are creating a new record within the GCL. So a record is basically the unit of information inside the GCL and has a record number, which can be used for reading later, as we'll show later. And of course, it includes data written by the client and the time of the log server when the information is received. Okay? So you don't need to put your own timestamp on that information, since the GCL or the GDP will already have it on its record. Now the log servers. The log servers can range from Raspberry Pis to desktop computers or laptops to huge cloud servers. Okay. However, since this stores the information that you are writing, it is much preferred that you have a large memory storage for your log server. Okay. It's also addressed using 256-bit identifiers and store logs created by other clients. Additionally, the log servers also controls the write access to the log. Okay, so once you request for an append to the log, the server will try to check if the key that you provided is consistent with the one you've used to create the GCL. So going back to one of the issues of the cloud before regarding security and privacy. Okay? So write access, as mentioned earlier, is controlled by the log server. Okay? As long as you have the correct key, okay, you will be able to append information. So even again, I mentioned earlier, even though other clients know the name of your log and they try to create or to append to that log, as long as they don't have the PEM file or the key file and a passphrase that you need to enter once you try to append, they will not be able to append to the log. Therefore, this reduces the possibility of rogue clients writing false information in the log to control the actuation of your system. Okay? Then for the read access, although anyone can read from a GCL, okay, as an application developer, you can actually encrypt first the information that you need to write. Then, basically, the read access is controlled by the application developers, by the application itself. So, if the application did not share the decryption key to you, then you will be able to understand or make use of the data that you receive from the GDP. So what are the benefits of the log structure? First, it is a proxy that supports a much richer set of queries. Okay, so since it is all in the GCL, you can actually try to query basically either the last few logs or records, or the records from a given time to the present, or even subscribe to a log so that any new information will be automatically given to you. Okay. Access control could be implemented at the log level. Again, for the write access, it depends on who has the key file. And similarly for the read access, depends on who has the decryption keys that the application used. Okay. The last, applications can be built by interconnecting log streams. So if you noticed earlier, the name of the log is not just only global log, but it's global channel or log. Since you can use this similar to a pipe, an operating system. Okay, so a pipe is basically a one-way communication. So if you have a system, like for example, for us, our Sense, we have a central service, then we have aggregators and applications that communicate with the central service, and need to have two-way communication between the central service and that application. So what we did is that we have one log that is created by the application and one log is created by the service that forms a two-way communication of the two entities. Okay, so you can use these different logs, tie them together to make a much powerful application. Okay. And just a brief background regarding the GDP routing protocol. So similar to the other entities inside the GDP, the routing protocol or the GDP routers uses a 56-bit identifier too. It uses click modular router platform that is developed by MIT, if I'm not mistaken. It is location independent. When you say location independent, it means that, as mentioned, as I've discussed earlier, you don't need to know the IP network address of the machine or the log server. You just need to know the name of the GCL, okay? And the routing protocol will be able to determine the fastest route to that log server. Okay? Self-configuring in a sense that clients can automatically determine routers closer to them. Okay? And self-organizing, which means that it allows new routers to gain sufficient info to join the overlay. Okay? So usually you have multiple routers in the GDP so that you can use different routers depending on your location as a client. So GDP router nodes again serve as entry points in the GDP. Basically, if I am a client, the first thing that I need to do is to connect to our router. Okay, to for the whole GDP to know that I am existing as a client. Okay? So it sends messages from the source, usually the client, to destination. Another can be another client or a log server. Okay? And we have two different nodes or types of router nodes. We have the primary nodes, which are not behind the firewall. Basically, these are the nodes that has public IP address. And we have the secondary nodes that are behind the firewall or on a local network. Okay? So these primary nodes, or all primary nodes, connect a full mesh connection, okay, between them. And all secondary nodes inside the network also create a full mesh connection. Okay? So they also trade information such as routing tables so that they can determine that this human readable name is actually this 256-bit identifier that is located in server X, for example. Okay? So they can actually determine, okay, that server, the primary server, is much closer to that log server, therefore I can route using that server, using that router instead of another router in a much far area. So that's the overview of the GDP. In summary, GDP is basically a data-centric model to solve IoT challenges. This also is still a work in progress. Okay? In fact, for the past months or years that we've been collaborating with the Swarm Lab, I think we've seen enough. Since our application has a lot of data, I think we've seen enough challenges on the GDP, and eventually our collaborators in Berkeley were able to solve those problems. Okay. So again, GCLs are single writer append only logs and are used for the main read and write unit. And GDP routing allows self-configuration and self-organization of the network to ensure that you have low latency in sending information from one client to another. Okay. So that's a summary of the GDP. So the next part will be a short demo on how to use the GDP in applications. On the right side, on the right screen, we'll have the terminal that I'll show the different samples of the GDP. Then on this left side basically is the instructions that I need to do. Okay. So if you want to install GDP for your own use, you can actually download it from their website. So it's in gdp.cs.berkeley.edu/redmine/projects/GDP. And you'll see there also, basically it's like a versioning control system, and where you can also file what do you call this? Bug reports. Okay, if you'll see there, it's actually active in having new commits every now and then. Okay. The GDP can be installed in any Unix-based OS. Okay, so we've actually tried to install it in Raspberry Pi, in Linux, and in Mac. Right, Ubuntu and Mac. Okay. So you don't need to worry about the packages that you need to install, since inside the GDP, is it okay if I sit down here for the laptop? Okay. So once you clone the repository of the GDP, actually you'll have this set of folders and files, and inside one of the folders actually is okay, so you don't need to worry again if you have a new box computer. Okay, this script will actually install all the needed packages for your operating system. So you just need to run the script and provide your root password for this to work. Okay. So once the GDP is installed, you only need to modify one configuration file. Actually, you don't need to modify this if you don't have additional routers. Okay, so this configuration file, which can be found in etc ep So this part of the workshop is a bit technical. Okay, so later I'll show Python scripts too. So basically, these are the basic configuration that the swarm, at least the GTP in your system needs. So these three routers are basically, they are the default routers in Berkeley. Okay, so for our case before, we've deployed a router here in Diliman. So I just need to put there the router name so that my system can access it for lower latency. Okay. Then, for example, on this part, we have another configuration, which is the retries configuration, if you want to modify the default retry values. So just one file to configure the GTP, then you're good to go. So the very first thing that you need to do if you want to interface to the GTP is to create the main unit of storage, data storage, which is the GCLs. Okay, so once you've installed this, there will be built-in programs in your system. For example, GCL create. Okay, so this is basically the man page of the GCL create. The GCL create, as the name implies, creates a new GCL. Okay, so what you just need to provide here, the basic information that you need to provide is the GTP server that you want, where you want to store your GCL, and a human readable GTP name. So for example, for my case here, we have GCL create space ph.edu.ubd.pcari.gdb.t. So that's a log server that we've installed here in Diliman. Okay. Then the second argument is basically the name of the log server. So as advised by our collaborators in Berkeley, they've requested us that if you're creating new GCLs, we use this format basically to avoid collision between different GCLs. Basically, for example, for their own GCLs, they use, of course, edu.berkeley.x, that's something. Okay, so for our case, we have ph.edu.ubd, the triple E that presents, then some other names that I need for my application. Okay, so let's try to create one. Okay. So for example, I want to create a new GCL that I want to store in the servers here in Diliman. So I have page. Then the name. So I've mentioned earlier that we have human readable names and we have 256-bit identifiers. Basically, later you'll see that this human readable name will be converted to the 256-bit identifier. So for example, for this case, I'll just follow what's shown here. So once you try to create a GCL, it will request for a PEM passphrase. It will be used later for validation of new appends. For example, I'll just create. Okay, so we have here GCL create new secret key is in something that PEM file. Okay, so this is the PEM file that I need to provide the application later for future appends. And basically this is the 256-bit identifier of the GCL. Okay. So for easier handling of PEM files, what I usually do is once I've created a new GCL, I rename the PEM file to the GCL name. Okay, so for example, for this case, okay. So after you create the GCL, of course the next thing to do is to try to write or to read from the GCL. Okay, so we have built-in GDP programs. Once you install the package, we have the GDP writer, and later we have the GDP reader. Okay, so for example, if I need to write, I need to provide the key file, basically the PEM file that the GCL create provided. Then of course the log name here. So I forgot to append that pen earlier when I renamed it. So once you try to write on it, it will again request for the same passphrase. So this is the security method of the GDPs to avoid other clients writing on your own GCL. Okay? So for example, hello world as the usual starting point. So it shows there that the record number is actually increasing, but the length of the data is always 0, and the timestamp, it says that there's no timestamp. But actually, in reality, I'm not really sure why it's that way. But in reality, in the GTP level on the server, they actually there's actually a length and a timestamp there. So to try to read on the GCL, you just need to use this program, the GTP reader, where the arguments here is either the first record or the number of records, or if you want to subscribe to that server or that GCL. But you can actually remove the other arguments. You just need, if you want to, just need to provide the GCL name, and it will print all the information, all the records within that log. So there, for example, since I've written two information or two records in the GCL earlier, I try to read it here, and as you see, this again, it uses your 256-bit identifier here, and it shows the correct length of the records and the correct timestamp. But again, the timestamp here is the timestamp of the log server and not the actual timestamp, and I haven't modified the time server, the time in the log server, so it uses this time. Okay, so for example, if I want to read just one file or one record, I can use the -n argument. So it will just read one record from the very start. Okay? The -s argument here basically is a subscribe argument. When you say subscribe, is that it will just open the GCL infinitely. Then every time that there's a new data, or for example, another client is writing information, you just need, it will automatically reflect to the reader. So usually use the subscribe command for when using the GCL as command channel for two-way communication. For example, if I mentioned earlier, I have a central service and I have an application. The central service will subscribe to the GCL created by the application. Then the application will subscribe to the GCL created by the central service. Okay, so basically, to facilitate real-time communication between the two entities. Okay, so The GDP is actually written using C language, but it's for programmers. We know that the C is rather difficult language in terms of syntax and other stuff, although it's powerful. Okay, so if you want a high-level interface with the GDP, you can use the Python infrastructure or Python wrappers that's also included in the package here. So for example, under the GDP folder, we have under the lang folder, languages folder, we have here the Python. Okay. So I'll just show some of the applications. Sample applications also included in the packages. Okay. So once you try to use this the Python. So, for example, when reading, you just need to use, or the structure basically is first, of course, you need to import. You need to import the GDP package, as shown here, the import GDP. Then, at the start of the program, you should do the GDP this function, GDP meet. Basically, it initializes all data structures that the GDP needed to connect to the services, to the routers, for examples. Okay. Now, for doing this, if you want to write, you need to do this additional command here. It basically gets the key file that you should provide to the application, and basically determines which encryption mechanisms are in place. Then determine the name of the GDP. Okay, so for this case, this one is the human readable name. Okay, so this function actually just converts the human readable name to the identifier as mentioned earlier. Then this function actually is the one that opens the GCL and gives it the GCL handle. So for us, familiar in file I/O, basically this is basically like a file descriptor. It is like the fopen of your programming language. Okay. Then for writing, what I just need to do for Python is to create a new dictionary with the data field. Then its value should be the one that you want to write to that record. Okay. Then just use the GCL handle that append, and it will be written on that what you call this, GCL. So we can actually try that one. So you have here the Python writer test.py, which is the application that I've used, the sample application. Then the name of the GCL, then the location of the PEM file or the key file that you need to use to verify the append. So again, you need to input the passphrase. Okay, I've input the wrong passphrase. Wait a minute. Okay. As I mentioned earlier, this is a work in progress. So actually, ano? Created yung log tsaka sample. Oo nga. Alam ko, maninay mo ba? Thank you for that. okay, the problem with this Python file is that doesn't have any notification that it's actually waiting for something. Okay? But since there's no error that's showing up, I believe it's already waiting for me to type something. So your battery might be low. So for example, something else. So if I try to read again this log, it should show the new information that I appended. So there's something else. Okay, so basically that's the way you write information. Then for the reading part, so we have different reading methods. So first, so the first reading method is that you read information by its record number. So this Python file read information based on its record number. As you've noticed, you don't need to do that encryption thing that you did in the writing Python. So for this one, you just need to provide the name of the GCL, create the handler, then read using this command or this function, GCL handle that read, then input the record number. Okay, so just need to do that. Another method in reading information here is to use the multi-read. So here in your test, basically you try to get information one by one, record by record. But in sometimes, there are times that you need to get information, a bulk of information, multiple records. So instead of sending different requests for each record, which might impose additional delays or latency, you can just request for a multi-read. Then the GDP will provide the information. Just one read, then the GDP will provide the records as events to you as a programmer. So the difference here is just this function. Basically, you just need to input or to tell the function which parts of the records will be returned to you as an event. So, for example, you have start number. For example, here, if you use multi-read 1.5, it means that you are getting 5 records from the first record. So that's what records numbers 1, 2, 3, 4, and 5. You can also use 3.0. If you use 0 as your second argument there, it means that you are requesting information from the record number 3 up to the last record. Or if you use the negative numbers for the first argument, you're requesting the records from the last records. For example, negative 10 will give you the last record in your list. Or the negative 5.2 will give you the 2 records from the fifth to the last. So if I have 10 records there, this will give me 6 and 7. So 2 records from the fifth to the last record. Okay. So this is multi-handle. Okay, so the return values here of the reading is an event type, and this datum is basically where it has a data field, it has a timestamp field, it also has a record number field and a signature field for the records. And the last part is the subscribe. So the subscribe basically is just, it's a blocking function. Okay, once you do this subscribe function, this function get next event will just block until a new information is written to the GCL. So as long as there's no new information, it will just wait and wait and wait until a new information is provided. actually I use this for real-time communication between entities or real-time saving of data logs from sensors. So these are the sample codes. It's also provided in the package if you want to download or if you want to download that package from their website. Okay. So as mentioned earlier by Sir Bong, this is our central service, or this is basically what we want is for our sensor networks to be scalable. Okay, so it means that you have different applications, you have different aggregators since you have different kinds of networks as mentioned earlier. So what we did is like similar to an OS, where basically these applications and aggregators are like files. Okay, and as a user, I can have we actually implemented or is trying to implement some sort of file permission type where each GCL has its own read-write permission depending on the level of access that you want. For example, if I know that this aggregator, for example, is affiliated to this application, I can actually inform that application or the GDP central service that I want for this part, for this GCL to be I want this GCL, I want only this application to read this GCL. Okay, so I can have also groups like in normal file operating systems. We have groups. For example, if this GCL are created by people in the same lab, I can have permissions that this application, for example, can only read from this group of logs. Or of course, we have the public read, which means that anyone can actually read your aggregator. So for my case, I need to limit the permissions for GCLs that has the internal status of my GCLs here. So what we did here is that in the central service, each aggregator has its own GCL status, which keeps track of the problems on the aggregator. So central service tries to poll all aggregators here, determine if they are still working properly. So if it's not, it should send a message to the application that is affiliated with that aggregator. Okay, so also, we have different channels mentioned earlier. We have channels from central service to the different applications and aggregators and vice versa for real-time communication. For example, if I have a temperature visualization application and it needs information for the past day, for example, the application will just request using this command channel. Then the central service will try to act on it, will try to check if this application can read this information from this temperature from these different sensors. Then if it's possible, then the central service will request, the central service will get the different, or will collate the different data from this sensor data storage. And it will create a new GCL for this application. So instead of opening different GCLs, because in our structure, what we did is that for each sensor, for each sensor, there's a different separate GCL, such that each GCL will only have one type of data. Okay, so if I need to create or to read different temperature data from different sensors, okay, I just need to ask the central service to give it to me instead of the application opening different types of GCL. And after all, I don't know which temperatures, I don't know what are the names of the GCL. So I just need to provide the MAC addresses of the sensor nodes. Then the central service will provide a single GCL that will contain all the information that I need, that I've requested. Okay? So somehow that's a flow of what we're doing. And so basically, aside from trying to collect information data from different sensors and trying to check if the application has permission to read information, this central service also is a routing service on its own. For example, there are applications that I need to control information here, or I need to control settings of my sensors. For example, temperature, I don't need it to sense every, say, 5 seconds because temperature changes are rather slow. So I can set, for example, from one application to set the temperature sensing to, say, 5 minutes. Okay? So the central service routes that command from the application to the aggregator and the acknowledgements from the aggregator to the correct application. Okay? So that's basically our central service that we've implemented. So that's all for the GDP. In the next part, actually, do you have any questions? Yes, sir. The central service, basically, we can think of it as the operate. Yeah, for now, it's a program that is running on a server. But it doesn't have the data. It doesn't store the data from the sensors. Basically, it just fetches from different data logs, routes it to the correct communication channels.
What happens if one of my aggregators? Sorry, if one of my aggregators down there are
For now, what we can do, for now, the system does is that if it notices that the aggregator is not updating its own status GCL, because each aggregator has its own status GCL, it will send a notification to the application that created that aggregator. So that's the current setup.
status? I can pull data from the aggregator.
No, sorry, if the aggregator closed down, you can still pull data from sensors that is connected to that aggregator. However, you cannot pull the new ones. Okay, so you can only pull the data that is stored before the aggregator what do you call this? Went down. Okay, so it is yeah. So in the aggregator that we actually implemented, we also have this capability that once the aggregator loses connection to GDP, it stores information temporarily on its own. Okay? So such that if the connection went up again, it will it will dump those unwritten data to the GDP.